I want you to try a little thought experiment with me today. Imagine you are sitting in front of a desktop computer back in 1993.
Oh, wow. Yeah, you're talking about the era of the heavy beige plastic monitors.
Exactly, the ones that weighed like 40 pounds.
Right, and that mechanical keyboard clacking away, the tower fan sounding like, I don't know, a small jet engine taking off in your room.
Yeah, and just the sheer friction of doing anything on those machines.
Yeah.
I mean, you boot up, which takes literal minutes,
Oh, yeah.
and then you're staring at this blinking command line interface. Now, sitting there in that very specific environment with that machine just humming in front of you, try to accurately predict the trajectory of the internet.
Which is basically impossible.
Right. Try to conceptualize algorithmic social media feeds or mobile banking or, global decentralized finance networks from that prompt.
Yeah, the conceptual leap from a Unix prompt to like a ubiquitous cloud-connected mobile society is, I mean, it's just too vast.
In a wall.
Exactly. The hardware limitations alone in 1993, they act as this massive cognitive blinder. You couldn't visualize streaming video because the bandwidth architecture physically couldn't support it, so your mind just, it doesn't even go there.
It's like trying to imagine a skyscraper when all you've ever seen is like a mud hut.
Yeah.
But take that feeling of impossible complexity, that total inability to map the future, and multiply it by 10.
At least by 10, yeah.
Because according to the source material we are unpacking in our deep dive today, that is exactly the technological maelstrom we are facing right now in early 2026.
It's a completely different scale.
Yeah, we are not looking at a linear progression anymore.
No, we are looking at compounding exponentials, things feeding into other things.
Exactly. And to make sense of this crazy landscape, we have a really massive stack of research today. So we're looking at a sprawling biographical profile of Marc Andreessen.
The Midwestern programmer who co-created the first visual web browser.
Right. But we're taking that origin story and we are pairing it with a high-level, really granular analysis of the global venture capital landscape as it stands today in 2026.
It's a great combination, really.
It is. And the mission of this deep dive is to map out how we got from that beige box in 1993 to today's multi-trillion-dollar global innovation boom.
And more importantly, to uncover the specific, highly counterintuitive strategy that, elite investors are using to navigate this total technological chaos.
Because it is chaos.
Yeah.
But I think it is worth establishing immediately that we aren't just looking at like a historical retrospective here.
You're right. Nor is it a dry analysis of fund economics. I mean, the venture capital ecosystem, for all its flaws, is currently the primary mechanism allocating resources to solve humanity's most intractable problems.
Yes, where the money meets the ideas.
Exactly. We are examining the architecture of how capital, elite engineering talent, and, wildly advanced technology converge to build the future.
So let's start with the architect of a lot of this, because his early environment provides this fascinating blueprint for how innovation actually takes root.
Marc Andreessen.
Right. He wasn't born in some Silicon Valley incubator. He was born in 1971 in Cedar Falls, Iowa, and raised in New Lisbon, Wisconsin.
Which is a very geographically isolated rural environment, the absolute heartland.
Yeah, exactly. And the source notes that by the time he was 8 or 9 years old, he was teaching himself basic programming.
From a library book, no less.
Right, on a Commodore 64. And he's actively writing games while the local culture around him was overwhelmingly focused on high school sports. Like, football was everything.
In the Commodore 64 detail, that's mechanically really important here.
How so?
Well, programming in BASIC on an 8-bit machine in the late 70s and early 80s, it required a very specific type of mental discipline. You had wildly constrained memory.
Oh, right, like literally 64 kilobytes.
Exactly. So you had to understand the hardware intimately to get the machine to do anything remotely interesting. It forces this ground-up, bottom-up understanding of computing logic.
You couldn't just rely on, massive processing power to cover up sloppy code.
No, not at all. Every single line had to be brutally efficient.
So that bottom-up discipline, it meets serious infrastructure in 1989. That's when he heads to the University of Illinois at Urbana-Champaign, or UIUC.
And he doesn't just go there for their computer science program, which was top tier.
Right. The campus actually houses the National Center for Supercomputing Applications, the NCSA.
Which was huge. The NCSA was one of only a handful of federally funded supercomputing hubs at a time when the rest of the world was operating on, slow dial-up
Like they were
modems.
connected to anything at all?
Right, if they even had a connection. This campus had high-speed network backbones. The source explicitly describes it as an early internet native environment.
So he basically steps out of this rural isolation in Wisconsin and walks directly onto the bleeding edge of global computing power.
The contrast is pretty staggering.
It is. And while he's working this part-time job at the NCSA in 1992 and 1993, he and another programmer there, Eric Brena, they build Mosaic.
And to really appreciate what Mosaic was, we have to look at what the internet actually was in 1992.
It wasn't the web we know today, that's for sure.
No, it was a collection of distinct, fragmented protocols. You used FTP if you wanted files, you used Usenet for news, Gopher to search for documents, and everything was entirely text-based.
So just lines of green or white text on a black screen.
Exactly. It was highly functional if you were an academic sharing, say, physics papers, but it was actively hostile to the general public.
It required specialized knowledge just to retrieve a single basic document.
Yeah, you had to know the exact path and the exact commands.
But Mosaic, they changed the paradigm by introducing a graphical user interface to the web. Like they integrated images alongside text for the first time.
Which seems so obvious to us now, but it was revolutionary.
Totally. And they utilized point-and-click hyperlinks. Plus, it had cross-platform usability, meaning it worked on Windows, Mac, and Unix.
And the mechanism of the hyperlink, that is the true breakthrough here.
Really? More than the images?
Yeah, because by embedding the navigation directly into the visual layout of the page, Mosaic removed that command line barrier we were talking about.
Oh, I see.
You didn't need to know the destination address anymore. You just clicked the highlighted text. It collapsed the entire distance between the user and the information.
It made it intuitive.
Mm-hmm.
And the adoption curve really reflects that collapse of friction.
Yeah.
The source says over 2 million copies of Mosaic were downloaded in his first year.
Which in 1993 is an astronomical number.
It's unheard of.
Yeah.
But here is where the narrative introduces this critical tension. And I want to push back on it a little. I look at this origin story, and I see technical brilliance meeting raw, powerful infrastructure. It's like planting this incredibly potent seed. But I'm looking at the Midwest in the early 90s, and I'm thinking it's like planting that seed in a desert. I mean, UIUC had the water, the computing power, but did they fundamentally lack the commercial ecosystem, the soil, to let a redwood actually grow?
That's a perfect analogy, and the source actually validates this entirely. The technical soil was rich, yeah, but the commercial ecosystem was entirely barren.
It just wasn't there.
Andreessen himself noted that the culture in Champaign-Urbana was completely unsuited for company building.
Because building a transformative tool just isn't enough to build an industry.
No, UIUC was optimized for academic research, for securing federal grants. The risk profile of that environment was basically zero.
They weren't trying to make billions of dollars.
Exactly. There was no mechanism in place to take a 2 million user software product, inject it with growth capital, hire a seasoned executive team, and go capture global market share.
It's two different worlds.
Academic environments prioritize discovery, right? But venture ecosystems, they prioritize scale. And the oxygen required to scale a consumer software product simply didn't exist in Illinois in 1993.
You need a whole different infrastructure for that.
You need legal frameworks that understand equity distribution. You need operators who know how to manage hypergrowth. And you need risk capital that specifically understands the economics of software, which is very different from manufacturing.
And that stark realization is what forces him to leave. So in early 1994, he packs his bags and heads west to Palo Alto, California.
Right into the heart of it.
Yeah. He goes to work for a small web security firm called Enterprise Integration Technologies, or EIT. He rents a 2-bedroom apartment, buys a Ford Mustang, and just immerses himself in a culture that is actively shifting its focus, from building hardware boxes to writing software.
The timing is incredible.
It is. But the source notes he gets bored at EIT after just 3 months.
Which is funny, but boredom in a highly optimized environment often leads to these high-variance outcomes.
What do you mean?
Well, if he was bored back in Wisconsin, he might have just sat in his room and written more code. But being bored in Silicon Valley meant he started taking meetings. He started talking to people like Jim Clark.
Jim Clark, who had already founded Silicon Graphics.
Right, so Clark already had immense credibility, deep pockets, and a fundamental understanding of how the Valley worked.
He knew the game.
He did. He looked at Mosaic, recognized the massive paradigm shift it represented, and literally within months of Andreessen arriving in California, they founded Mosaic Communications Corporation.
Which immediately triggers a legal threat from UIUC over the naming rights.
Of course it does.
So they have to rapidly rebrand to Netscape Communications. But honestly, the speed of this kit highlights exactly the commercial machinery that the Midwest lacked.
Absolutely. Think about what Clark was able to do. He immediately secured funding, navigated the whole IP dispute with the university, and recruited the original engineering team right out of Illinois to move to California and build a superior commercial-grade browser.
All in a matter of months. And they launched Netscape Navigator in late 1994. By mid-1996, they command over 75% of the browser market.
It was total dominance.
It was. And the 1995 IPO prices Netscape at nearly $3 billion on its first day of trading. The source identifies this specific event as the catalyst that effectively kicked off the dot-com boom.
It was the starting gun.
But looking at this timeline, the transition from arriving in California in early 94 to a $3 billion public company in 95, it happens in roughly 18 months. So I have to ask, was this just a classic case of being in the right place at exactly the right time? Like, could anyone with a browser have struck gold in 1995?
It's a fair question, but no. Timing is a prerequisite, sure, but it doesn't guarantee a monopoly. That 75% market share wasn't an accident. It was achieved through a highly aggressive, deliberate distribution strategy.
How so? What did they do differently?
Well, they made the browser completely free for academic and nonprofit use. And for commercial users, they allowed this incredibly generous evaluation period. They consciously optimized for ubiquity before they optimized for revenue.
Get it in everyone's hands first.
Exactly. It was a ruthless execution of network effects. The more people who use Netscape, the more developers optimize their web pages specifically for Netscape, which then further entrench the browser as the default lens for the internet.
So the execution is really what solidified the legend. It wasn't just luck, but there is a secondary, maybe more durable byproduct of that execution that the source brings up. It introduces this concept of the Netscape halo.
Yes, the halo. By co-creating the browser that brought the internet to the masses, Andreessen acquired this reputation as the, quote, patron saint of the internet.
That's quite a title.
It is. And in the venture ecosystem, a reputation of that magnitude fundamentally alters the physics of company building.
It creates this aura of unshakable credibility. So when he co-founded LoudCloud in 1999 with Ben Horowitz, where they were pioneering early cloud infrastructure, eventually selling to HP for $1.6 billion, that halo acted as a massive gravitational force.
Right, because reputation lowers the cost of capital and the cost of talent. Think about it. The best engineers in the world, they want to work with the guy who built the web.
Makes sense.
And the most powerful institutions are eager to deploy their capital into his ventures. The halo creates this self-fulfilling prophecy of access. Everyone wants to be in his orbit.
And that access, combined with the really deep bond, the operational scars forged with Ben Horowitz during those LoudCloud years, because that was a tough period going through the dot-com crash, that becomes the foundation for their next act.
The one that changes everything.
Exactly. In July 2009, they launched their own venture capital firm, A16s, with a $300 million debut fund, betting heavily on the thesis that software is eating the world.
And the 2009 macro environment is crucial context here.
Right. We were right in the depths of the global financial crisis.
Exactly. Traditional venture capital was highly conservative at that moment, leaning way away from early-stage risk. And the standard VC model at the time was notoriously thin on actual operational support.
Yeah, the old model was, it's kind of like a rich uncle giving you a check and saying, good luck, kid.
Yeah.
Like the pre-2009 model operated as a fragmented collection of generalist partners.
They'd offer some money, maybe a little advice, and demand a board seat.
Right. A partner would source a deal, write the check, and that was mostly it. It was highly hands-off. You got the capital, but you were entirely on your own to figure out the execution.
And the A16's innovation was what they called the platform venture capital model.
How does that differ?
They observed that technical founders often lacked the highly specialized, boring business skills required to scale an enterprise. I mean, a brilliant software engineer or cryptographer doesn't necessarily know how to build a global enterprise sales motion, right?
Or how to run a marketing campaign or deal with HR.
Exactly. Or how to navigate an adversarial congressional hearing. So they decided to internalize those functions. They treated the VC firm itself like a full-service operating company.
So instead of the rich uncle, it's like showing up to a street race and being handed the keys to an F1 car, along with an entire 500-person pit crew.
That's a great way to visualize it. Today, by early 2026, they employ over 500 people across these highly specialized practices. They have dedicated teams just for executive recruiting, talent, marketing, policy, legal, engineering, go-to-market, finance.
They proactively help the portfolio companies scale. They don't just wait for the founder to ask for help.
Right, and it creates this incredible virtuous cycle.
Break that down for us.
Well, when a firm offers an entire ecosystem of systemic product-first support, it inherently attracts the absolute best founders. Because why would you take money from the guy who gives you nothing else when you can get the 500-person pit crew?
Obviously, you take the pick, true.
And then those elite founders utilize the platform to scale faster and navigate hurdles that would normally destroy a lesser supported startup. That accelerated growth generates massive financial returns.
Which then attracts larger, limited partner investments, the LPs enabling even bigger funds. It's a massive, self-sustaining flywheel.
Exactly.
And the scale of this flywheel by early 2026 is, frankly, almost difficult to comprehend. The source indicates A16z now manages over $90 billion in assets.
$90 billion.
And in January 2026 alone, they recently raised over $15 billion across their funds, just in 1 month.
To contextualize that figure for a second, $15 billion is roughly 18% of all the venture capital dollars deployed in the United States in the entire year of 2025.
Wow.
It is an extreme, unprecedented concentration of capital.
But the platform model isn't just a luxury for these startups anymore. The source argues it's a structural necessity for modern tech scaling.
Because the market mechanics have changed. Startups are no longer going public within 18 months like Netscape did in the 90s.
They are staying private for a decade or more.
Right. The regulatory burden of going public has increased dramatically, and simultaneously, the availability of massive pools of private capital allows these companies to just fund their growth without dealing with the public markets.
No quarterly earnings calls to worry about.
Exactly. But when a company is staying private until it reaches a $10 or $20 billion valuation, it requires hundreds of millions of dollars in follow-on funding. And it requires a level of operational complexity that a traditional, hands-off VC simply cannot manage.
Which brings us to the actual track record. Because look, a massive pit crew is only useful if you bet on the right drivers.
A 500-person staff means nothing if the underlying asset allocation is flawed.
Right. But A16z has backed over 1,000 companies. The source notes they have 124 plus unicorns, over 35 IPOs, and over 247 acquisitions. Let's examine the mechanics behind some of these legendary wins, starting with Airbnb in 2011.
That's a fascinating one. Partner Jeff Jordan led the Airbnb investment, and the core mechanism he spotted there is the two-sided marketplace dynamic.
Which are notoriously hard to build.
Incredibly hard. Because you face the cold start problem. You need hosts listing their homes to attract guests, but you need guests looking for rooms to convince hosts to list their homes. It's a chicken and egg nightmare.
But once that liquidity is established, the network effects create a massive moat, almost impossible for a competitor to break.
Exactly. But the challenge for Airbnb wasn't just marketplace liquidity. It was a sustained, incredibly hostile regulatory assault. You had hotel lobbies and municipal governments in major cities like New York and San Francisco actively trying to shut them down.
And this is where the platform model proves its thesis, isn't it?
Completely. A traditional VC might look at that severe regulatory risk and just pass. They'd say, too hard. But A16z deployed their internal policy and government relations teams to actively help CEO Brian Chesky navigate and shape that regulatory skepticism.
They didn't avoid the friction. They engineered a path through it. And that led to a $47 billion valuation at their initial IPO in 2020.
Massive win.
We see a really similar dynamic with Coinbase in 2013. Andreessen backed it early, but not just as a speculative asset. He viewed Bitcoin as a fundamental computer science breakthrough.
Right, the breakthrough of distributed consensus. But operating a cryptocurrency exchange in 2013 meant navigating an absolute labyrinth of federal and state financial regulations. Nobody knew what the rules were.
It was the Wild West.
It really was. It required building bank-grade compliance infrastructure from scratch. And again, the A16 platform provided the operational and legal help to allow CEO Brian Armstrong to build an institutionally trusted platform in a largely unregulated, chaotic sector.
And that foundational compliance is exactly what allowed them to reach an $86 billion IPO in 2021.
Yes.
Then you have Slack in 2014, backed by Chris Dixon. And this one is wild to me. Stuart Butterfield was running a gaming company that was basically failing. Slack was literally just an internal communication tool they built for themselves to collaborate on the game.
Which is the hardest maneuver in technology, the pivot.
Giving up on the dream.
Yeah, it requires a founder to abandon their original vision and have the humility to recognize the value of a tangential byproduct. Slack's genius was bringing consumer-grade software design into the clunky enterprise sector.
Yeah, old enterprise software was so ugly.
It was terrible. And Slack utilized this bottom-up adoption model where individual teams inside a company adopted the tool organically before it was ever officially mandated by the IT department.
And A16s helped them pour fuel on that fire, scaling it to a point where Salesforce acquired them for $27.7 billion in 2020.
Incredible return.
And finally, GitHub in 2012. This was a $100 million bet on a platform that fundamentally catalyzed how developers collaborate by leveraging the Git protocol. It led to a $7.5 billion Microsoft acquisition.
So look at these 4 examples.
Renting out air mattresses on strangers' floors.
Trading decentralized digital magic internet money.
Pivoting from a failed, weird video game.
And hosting open source code repositories.
None of these fit the traditional mold of a safe corporate bet. To an outsider, they look like a chaotic mess. So how does A16s manage to see the inevitable future in what looks like chaos to everyone else?
They look for visionary builders who possess the capability to execute at extreme scale, and they rely heavily on ex-founders as general partners, people who have battle-tested playbooks.
They've been in the trenches.
Exactly. Because A16s provides institutionalized policy, government relations, and legal compliance teams, they simply aren't afraid of regulatory skepticism. They actively seek out founders disrupting highly regulated spaces like finance or real estate, and they help them dismantle those barriers systematically.
And this ability to navigate hyper-complex, heavily regulated, and chaotic environment, it is no longer just a competitive advantage. As we shift our focus to the global VC landscape in 2026, the source makes it clear. This capability is an absolute requirement for survival.
Because the macro environment has fundamentally detached from historical norms.
The numbers are staggering. In 2025, global startup funding reached roughly $425 billion. That's the 3rd highest on record. And early 2026 is already shattering first-quarter records.
We are seeing a velocity of capital deployment that is just massive.
And the United States continues to dominate, capturing about 64% of that global total, around $274 billion. And within the U.S., despite years of headlines predicting the death of Silicon Valley, the Valley still holds the crown.
It still commands roughly 40% of all U.S. seed and Series A capital.
So the decentralization to places like Austin, Miami, NY, Boston, it's happening, but the Valley is still the center of gravity.
The density of engineering talent and risk capital there is still unmatched.
But the source highlights a highly alarming concentration within that data. In 2025, artificial intelligence captured 65% of all U.S. venture capital deal value.
65%. Let's dissect the mechanics of that concentration because it's dangerous.
Is Silicon Valley just becoming this incredibly wealthy echo chamber, completely blind to other innovations? Because 65% in one sector feels insane.
The source absolutely agrees this is the primary danger. Density of talent is a superpower, but thematic concentration is a massive risk. When 2/3 of the capital flows into a single sector, you distort the entire ecosystem.
How does that distortion play out?
Well, the frontier AI models being built require massive compute resources, specifically GPUs. So the venture capital is effectively functioning as a pass-through mechanism.
What do you mean?
The VC gives, say, $1 billion to an AI startup, and that startup almost immediately hands that capital over to hardware providers like NVIDIA or cloud providers to secure compute clusters.
Right.
The money doesn't stay in the startup ecosystem.
Oh, wow.
And it creates a brutal winner-take-most dynamic. The frontier AI labs are hoarding the talent and the compute, driving valuations to astronomical multiples. Meanwhile, founders who are building amazing things outside the AI bubble, they are starved for capital.
This is an AI mono economy.
Yeah.
And this vulnerability becomes even more stark when we contrast it with the global data, specifically looking at India and China.
Right. The source notes India hit roughly $16 billion in VC funding in 2025. That's up 1.2x. But the hallmark of the Indian market right now isn't blitzscaling or chasing hype.
It's disciplined unit economics.
Exactly. They are building an ecosystem prioritized for sustainability and actual profitability, maturing towards sustainable growth over pure, reckless scale.
And then China represents an entirely different strategic paradigm. The source details an ongoing state-led hard tech renaissance. The Chinese government is actively directing capital away from consumer software and internet apps.
They don't care about the next social media app. In late 2025, Beijing launched state-backed investment vehicles totaling over $21 billion, specifically targeting what they term new quality productive forces.
Meaning they are heavily indexing on the physical, atomic world, quantum computing, advanced robotics, semiconductor manufacturing.
It is a profound strategic divergence from the U.S.
The U.S. is pouring two-thirds of its venture capital into software algorithms, while China is highly deliberate, utilizing state-directed capital to endure the long maturation cycles of physical technology.
And we should clarify, the source isn't taking a political stance on which system is morally right, but it's pointing out the structural risk. Software yields higher immediate margins and faster returns, which aligns perfectly with standard U.S. VC fund cycles.
Right. VCs want their money back in 7 to 10 years.
Exactly. But hard tech requires massive capital expenditure and a decade of patient development before commercialization. The U.S. market is optimizing for rapid algorithmic software iteration, while the Chinese model is geared toward the slow build of physical infrastructure.
And this overwhelming U.S. concentration of capital into a single sector AI software is especially precarious because, according to the analysis, 2026 is not just experiencing one technological wave.
Not at all.
The 1990s had the commercial web. The 2010s had mobile and cloud computing. But 2026 is experiencing 10 parallel internet-scale megatrends converging simultaneously.
It's the tech maelstrom.
Yes. And we need to interrogate the mechanics of these trends to understand the sheer scale of the threat, the chaos.
And the crucial framework here is not just listing the individual technologies, but understanding that every single one of these 10 trends has the standalone capacity to create massive, trillion-dollar market disruptions.
Right. So let's run through them organically. Let's start with the one absorbing all the oxygen AI.
Yes.
But specifically agentic and physical AI. We aren't just talking about chatbots writing emails anymore.
No, the mechanism of agentic AI moves way beyond static generation. We are talking about agentic architectures that can execute complex, multi-step goals autonomously.
Like digital workers.
Exactly. An agentic system utilizes a reasoning loop. It's given an objective, it formulates a plan, it executes the first step by interacting with external software environments like booking a flight or writing and testing code. It analyzes the result and dynamically adjusts its next step based on the feedback.
And when you take that agentic logic and you give it a physical body in the real world, you enter the second trend, robotics and embodied AI.
Which is finally overcoming Morveck's paradox.
What's that?
It's the observation that high-level reasoning is easy for computers, but low-level sensor and motor skills like walking upstairs or folding a shirt are incredibly difficult. Traditional robotics relied on rigid, pre-programmed spatial mapping.
Like factory arms that do one motion perfectly.
Yeah.
But if you move the car part 1 inch to the left, the robot fails.
Right. But embodied AI solves this by utilizing end-to-end neural networks. The robot processes raw camera data and outputs motor control directly. It learns physics and manipulation through massive simulation.
So this unlocks general-purpose humanoid robots capable of operating in messy, unstructured human environments. That fundamentally alters the economics of physical labor.
But, and here's where the intersections happen, operating millions of embodied agents and training these massive AI models requires insane amounts of energy.
Which leads directly to our third and fourth intersecting trends. Climate tech, specifically energy abundance and advanced materials.
The compute demands of frontier AI and robotics are violently exposing the limitations of our current baseload energy grid. Intermittent renewables like wind and solar, they just cannot sustain the 247 power draw of gigawatt-scale data centers.
You need baseload. So this is forcing massive capital deployment into next-generation geothermal and advanced nuclear.
Right, small modular reactors and even magnetic confinement fusion pilots.
But to build those high-temperature reactors, you need the advanced materials trend.
Exactly. Material science is being revolutionized by AI computational simulation. We aren't discovering materials through trial and error in a lab anymore. We are designing metamaterials, high-temperature superconductors, and advanced alloys at the atomic level.
Which feeds right into the fifth trend.
Yeah.
Quantum computing.
Right.
We hear the term constantly, but the mechanism is what matters here. It doesn't just mean a faster processor.
No, it fundamentally changes the algorithmic complexity of certain problems by utilizing superposition and entanglement. A classical bit is binary 0 or 1. A qubit exists in a superposition of states.
allowing quantum algorithms to explore vast probability spaces simultaneously. And while the source node's error correction remains a monumental engineering challenge, the realization of a fault-tolerant quantum system will instantly revolutionize chemical simulation.
And it will simultaneously break modern cybersecurity, which is our sixth trend.
Post-quantum cryptography. Because the RSA encryption that secures the entire global financial system right now, it relies on the difficulty of factoring massive prime numbers. A functional quantum computer solves that math instantly.
So we are witnessing a massive infrastructural arms race to implement quantum-resistant cryptography before large-scale quantum hardware comes online.
And this arms race dynamic bleeds perfectly into the seventh trend, defense tech and dual-use systems, what A16 categorizes as American dynamism. The mechanics of warfare are shifting toward asymmetric autonomous systems.
We are seeing the deployment of drone swarms operating on localized mesh networks, entirely independent of GPS.
And these dual-use technology systems, built for commercial applications, but highly lethal in defense contexts, they're forcing governments to bypass traditional defense contractors and integrate directly with agile venture-backed startups.
Just to maintain technological superiority.
Meanwhile, the eighth trend pushes our infrastructure off the planet entirely, commercial space and orbital infrastructure. The fundamental metric here is the cost to launch a kilogram to low Earth orbit.
And fully reusable launch vehicles have collapsed that cost curve by an order of magnitude. This enables mega constellations providing global broadband, completely untethering internet access from terrestrial infrastructure.
Then we look inward at the biological hardware with our ninth trend, biotechnology and synthetic biology. We are treating biology as an engineering discipline.
Viewing DNA as source code, we are engineering synthetic microbes to manufacture industrial chemicals and designing customized therapeutics based on individual genomics.
And finally, the 10th trend, bridging the biological and the digital. Brain-computer interfaces or neurotech.
The shift from low-bandwidth external sensors to high-bandwidth, invasive neural arrays. Decoding the electrical spikes of the motor cortex to allow paralyzed individuals to operate digital interfaces at the speed of thought.
So just to recap the chaos, we have agentic AI, embodied robotics, energy abundance, advanced materials, quantum computing, post-quantum cyber, defense tech, orbital infrastructure, synthetic biology, and neurotech.
All parallel, all self-reinforcing.
I mean, I compare the 1990s internet boom to, learning to juggle 3 tennis balls. Investing in 2026 is like trying to juggle flaming chainsaws while riding a unicycle.
It's existential chaos for an investor.
How does any human investor, even an A16's partner, avoid getting distracted by the blinding flash of the newest shiny technology?
Because traditional linear VC thinking is dead. The true chaos of 2026 isn't the list itself, it's the exponential intersections between them.
Right. AI plus biotech equals 100x drug discovery speed. Quantum plus materials equals new energy paradigms.
The sheer velocity of these intersections means that if you chase the technology, you will always be a step behind.
The capital and attention are hopelessly fragmented. LPs demand rapid returns, but deep tech requires patient, decade-long capital.
So investors risk chasing hype cycles.
To survive this overwhelming chaos, the smartest capital in the world is adopting a seemingly counterintuitive strategy.
The winning VC strategy in 2026. Ignore the specific technology du jour. They ignore the technology entirely.
Which is wild. The North Star thesis.
Instead of obsessing over the tool, they obsess over founders who are maniacally focused on solving humanity's most painful, intractable problems.
Climate resilience, affordable energy, scalable healthcare, secure supply chains.
Exactly. A problem-first founder treats AI, quantum, and robotics simply as tools in a toolbox, not as the mission itself.
I love this. It's like a master carpenter focusing purely on building a hurricane-proof house rather than obsessing over the brand of hammer they happen to be holding today.
That's the perfect way to look at it. They build anti-fragile companies, organizations that compound across technological waves rather than riding just one and wiping out when it crashes.
And the historical proof for this is rock solid. Amazon solved the problem of commerce infrastructure. Google solved information access. Tesla and SpaceX solve energy and multi-planetary survival.
The problem remains constant. The technological solution is highly fluid, and this ties beautifully back to the beginning of our deep dive, Marc Andreessen at the NCSA.
Right. He didn't build Mosaic to prove a point about C++ code. He built it to solve the problem of an unreadable, inaccessible internet.
He solved the problem of friction. Technology is transient, but world-class entrepreneurs who fix what is broken are eternal.
To summarize this incredible journey, We trace the path from a farm boy with a Commodore 64 in the Midwest, migrating to the high-bandwidth infrastructure of UIUC to build the lever that opened the internet.
We watched the commercial machinery of Silicon Valley turn that lever into Netscape, kicking off the dot-com boom.
And creating that foundational halo of credibility. A credibility that allowed the complete architectural redesign of the venture capital model itself, transitioning to a massive $90 billion platform capable of managing the complexities of modern private markets.
And we saw why that platform scale is the baseline requirement for navigating the jaw-dropping reality of a 10-front technological explosion in 2026.
We've seen that to survive the chaos, the ultimate strategy is a relentless focus on the problem, not the shiny new tool. Which brings me to a final provocative thought I want to leave you with today.
Let's hear it.
If the most powerful, resource-rich investors in the world, people managing $90 billion, have realized they cannot keep up with the technology and must instead focus purely on the problems, how much of your own time are you wasting trying to learn every new tool or hack?
It's a great question.
Are you endlessly scrolling trying to keep up with the latest AI update instead of relentlessly focusing on solving the actual high-value problems in your own life and work? Think about it. Thank you for joining us on this deep dive. Stay curious.